Okay, part A, write an equation of the line tangent. So as soon as I hear those words, you should be thinking I need a slope, I need a point, but they already give you the slope, which is f prime, and this is a calculator problem, so all you need to do is plug in 3 and 4x, and I get 2.3428. There's my slope. And then they give you the point, which is 3, 6. Write the equation of the tangent line. Y minus 6 equals 2.3428 x minus 3. And then they want you to use this to approximate f of 3.1. So this is an approximation to the actual function. So I'm going to go ahead and plug in 3.1 for x. So y is equal to 2.3428. 3.1 minus 3, move that 6 over, and if I go ahead and punch this on the calculator, f of 3.1 is approximately 6.23428 using the equation of the tangent line. Part B, we're going to use Euler's method, and remember we're going to create our table here. We need the point, which is your xy value. We need the slope, which is your dy dx, or really in this case it's f prime of x, which is given as 1 plus e to the x over x squared. And then we also need change in y, which is dy, which is dy over dx times delta x, or dx again. So the point that they're asking you to start with is that x equals 3, and we know that the y coordinate at that point is 6. And from part A, we already calculated the slope at that point. It's 2.34283. So to figure out what the change in y is going to be, I'm going to take that slope and I'm going to multiply it by dx. And they tell you to use a step size of 0.05. So that's my delta x. So if you punch this out on the calculator, this is 0.11714. So my next x coordinate becomes 3.05. because you're increasing the x value by 0.05, and then you're going to add this value to your 6, which ends up being 6.1171 something. Just make sure you're storing these values in your calculator as you go along, and then just repeat the process again. So there's my new x value, plug it into the f prime. This ends up being 2.377 something. This ends up being 1.18867 something. And then your final point is 3.1, comma 6.236. Make sure you circle the answer or identify what number is the answer to your problem. They're asking, and this should be something close to this. The idea is in part A, you're using a tangent line to approximate this function. In part B, you're doing Euler's method to approximate the function, so they should be relatively similar. Okay? And the second part of this problem says use f double prime to explain why this is less than the actual value of the function. So anytime they ask you about is this less, over, under approximation, over approximation, you're thinking about your concavity because this is a tangent line. So they said to use f double prime. So first thing you should do is go ahead and come up with f double prime. So I'm going to go ahead and use the quotient rule on f prime to come up with f double prime. So derivative of the top is e to the x times the bottom minus derivative of the bottom is 2x times the top all over denominator squared. Okay, I'm going to simplify this a little bit. Okay. Now you have a calculator. Now if you look at this graph at 3.1 or any values around 3, you're going to notice that this is positive. So at x equals 3.1, f of x is concave up because f double prime is positive. So think about what we learned about the tangent line. What does that tell you about your tangent line? It is under the curve if the graph is concave up. So the line is the below, so approximation is less, which is what they're asking you to check. So they're looking for, did you understand that the f double prime is positive, which means the function is concave up. Lastly, they want you to use this to evaluate f of 3.1. Well, this is your fundamental theorem. When I integrate f prime, I get f. We take the upper bound, subtract off the lower bound. This, just type it into your calculator. And then this f of 3 was given is 6. So f of 3.1 is really 6 plus this antiderivative. Just use my calculator, and this is what I get. So to get the credit, they're looking for, do you understand this fundamental theorem?